already spent some time with, so I don't think this is going to be anything new or confusing for you. We've already done some of these. It says draw a picture, write an equation, and solve it, section 4.8 in our notes. Alright, so here we go. Here's the picture. Notice the picture for all these is the same. All of these angle of elevation and depression problems that get this nice little right triangle. So for the first one, it says find the angle of elevation. So find the angle of elevation. That's going to be my x. Where do I put that? Where do I put the angle of elevation? Always. Right here. Right? That's where it goes. The angle of elevation or the angle of depression, either one's going to go right there every time. Of a bird in the top of a tree, so here's the bird in the top of the tree, from a point on the ground, there's the point on the ground, the point on the ground 100 feet from the base of the tree. So where does 100 go? The bottom, 100 feet from the base of the tree. The bird is 18 feet above the ground. So there's the picture, right? Now we need an equation, and the equation is going to be sine, cosine, or tangent. So look at the sides that you've got. Here's your angle. Look at the sides that you've got, and tell me what equation you're going to use. They're videotaping out there for some reason. Okay, so what do you decide? What are we using? Tangent. So we're going to say tan x. Remember, when you write your equation, it's always tangent angle, sine angle, cosine angle. The angle always goes with the function. So tangent equals what? 18 over 100. Opposite over adjacent. Now this is one of the weird ones. You can't type this into your calculator like this. It's not going to work. When the angle is the variable, what do we have to do that's a little bit different? Well, to get x by itself, the only way to do that is to use that button. Remember that from the other day when we did this? You need to use your second tangent or second sine, second whatever button to find the answer. Alright, so I'm going to press second tangent, 18 divided by 100, and did you get 10.2 degrees? So my angle of elevation is 10.2 degrees. Now, did anybody type this in and get something other than 10.2? Everybody got 10.2. Awesome. Okay, let's look at the next one. Find the distance from a worm on the ground to a bird in the top of a tree. If the bird's angle of depression is 24 degrees, where does the 24 go? Right here. And the tree is 19 feet tall. Find the distance from a worm to the bird. So where does the x go? Hypotenuse. There's the worm, there's the bird. Find the distance from the worm to the bird. Okay, equation, sine, cosine, or tangent. Sine. Why did we pick sine? Sine 24. Remember, the 24's got to go with the sine. Why did you pick sine? Opposite and hypotenuse. That's exactly right. Those are the two sides you have, opposite and hypotenuse. Now, this one I'm going to be able to type in pretty easily, but I have to do some adjusting first. You always got to get rid of your denominator. So x sine 24 equals 19. And then what will x equal? 19 divided by sine 24. Now don't use this button. You have your angle, so you just use your regular sine button. 19 divided by sine 24 46.7 feet. Oh shoot, it says round to the nearest hundredth. I haven't been paying attention to directions. So that'd be 7.1. And the last one would be actually 10.20. Okay. Everybody good with that? One more. How tall is a flagpole? How tall is a flagpole that casts a 23-foot shadow when the angle of elevation is 32 degrees? Alright, where does the 23 go? On the bottom. That's where shadows are. Shadows are on the ground. Shadows are on the ground. So that's where the 23 goes. Good. Now, equation. Sine, cosine, or tangent? Tangent, because you have opposite and adjacent. So tan 32 equals opposite over adjacent. So we'll get rid of our denominator. 23 tan 32 equals x. And we can type that in. 14.37. Feet. Everybody okay with those problems? They're just what we did before. There's nothing, we didn't do anything different than what we did before. Lamuna? 46.71 is what you should have gotten when you typed it in on your calculator. When you type 19 divided by sine 24. All right, number 2, we're going to draw the path of a ship. Now, this is draw only. So you're going to draw a picture, but you're not going to actually do anything with it. That will be in the next chapter. So we're going to draw the path of a ship. All right, so here's my compass. Now remember, if you're using a compass, you got your north, south, east, west. But the labels in degrees are different than normal angles, like you just did on your quiz. On the compass, they go this way, right? Which is different than how they go in regular trigonometry. I didn't make the rules. I'm sorry it's that way, but it's that way. So this is the compass. All right, so he sails for 4 hours on a course of 125 degrees. So 125 degrees is going to be down here somewhere. And he's going 4 hours. So that's 4 hours on that course. And that's 125 degrees. Then he changes. Okay, so now he's here. But he's changing direction now. And he's on a course of 195 degrees. So that's going to look like this. Because, again, on the compass, it goes this way. So 195 is going to be just past due south. So that's 195 degrees. Now we did some of that the other day, but here's the new part. The ship is traveling at a constant speed of 10 knots. Knots is a speed. You've heard that word before, right? Ships, planes, anything that travels long distances is, the speed is given in knots, not in miles per hour, but it's the same thing. A knot mile per hour. So it's a speed. That's all. It's like saying he's going 10 miles an hour. So the reason that's important is because on your course here, you need to label these. So this guy, remember the blue one, his first path, it was for 4 hours. 4 hours at 10 miles per hour. So how long is that blue thing? 40. And the unit on that is actually nautical miles. Nautical miles. But if you put miles, I would have marked that wrong. Nautical miles are a slightly different length than regular statute miles, regular land miles. I'm trying to remember in the recesses of my brain. A statute mile is 5,280 feet. I think a nautical mile is 6,080 feet, something like that. They're slightly bigger. All right, and then what about the red vector? How long is that going to be? He went for 1 hour, so it is going to be 10 nautical miles. So that's it. That's a picture. That's all you had to draw. That's it. You drew the path.
Should I put NM for sure?
Yeah. Okay, so let's try the next one. Anytime it's talking about a ship and all that, you want to set up your compass and start at the origin. So now it's an airplane. He's on a course of 50 degrees. So remember, on the compass, they're labeled like that. So 50 degrees is going to look like that. This is 50 degrees. Now, he went at a speed of 250 knots for 3 hours. So 250 miles an hour for 3 hours. How long is that? 750 nautical miles. Okay? And now he's here. On that whole way, now he's here. What does he do now? Then he goes at a speed of 300 knots for 2 more hours on a course of 350 degrees. Now, where is 350 going to be? That's going to be almost straight up, right? It's just going to be over here slightly. This is 350 degrees. Because remember, on your compass, straight up is 0. So straight up would also be 360. Now, I'm out of room. That should actually be a little bit longer because how long is that? He went for 2 hours at 300 knots. So that's 2 hours at 300 miles an hour. So how far is that? 600. So that actually should be longer. It should be up here somewhere, but I'm going to have to stop it. That's 600 nautical miles. It really should be up here in the red flowers. And that's it. Just drawing a picture of it. That's it. Oh man, we did a lot of material. So let's start pulling all the pieces together. I will have figured out, now that we finished the notes, I will figure out when your test is. I told you before I thought it would be the beginning of next week, and I still think that, but I'll pin it down definitively for you soon. So, gave you these a long time ago. These are your practice tests. Actually, this time I wrote pre-tests for some reason, but they're your practice tests, your pre-tests. And wow, a lot of problems. Here we go. Let's get started. Number 1, I'm on practice test number 1. It says change into degrees 3 pi over 5. Well, you do this automatically. You did this on your quiz today. What's pi? 180 divided by 5. I don't know, we don't do that one very much, so let's, what 180 divided by 5 is 36. So then I have to take 36 times 3. You get 108. But here's the thing, you've done that a million times. That is not anything new or different. 180 divided by 5 times 3. So no matter what these numbers are, you know exactly what to do. 180 divided by 5 times 3. All right, now the other way, we don't do this as often. Change that into radians. Do you remember how to do that? Change that into radians. That's your proportion. So those of you that remember the proportion, that's the proportion. And what does that proportion look like? Pi over 180. Pi over 180. And you match those two up because aren't they the same? Isn't pi 180? So they're matched. Equals something over 250. Yep, this is a match. You want to know, you want to make this a match. So cross multiply. And divide. And then, of course, you need to reduce that. So anytime you have zeros, you can cross those out. I think that's it, right? So it's 25 pi over 18. Is that bringing back some memories? That was the first day of this chapter, believe it or not. A long, long time ago. All right, find the measure of the arc determined by an angle of 40 degrees in a circle with a radius of 10. Oh, this is a blast from the past. Anybody remember anything about arc length? Will?
Radians over radius.
Radians times radius. Very good, Will. So arc length equals radius times radians. Very, very good. So x, which is the arc length, that's what I'm looking for, is going to be the radius, which is 10, times the radian measure of the angle. But what do I have? The degree. So I'm going to have to do this to get the radian measure. So I need to find this number, so I'm going to over to the side. Pi over 180 equals something over 40. So 180x equals 40 pi. So 40 pi over 180. Uh, 2 pi over 9. Does that look okay? Now, don't get excited. That's not the answer. That is what goes into Will's formula. Remember, arc length is radius times radians. So now we know the radian is 2 pi over 9. So now we can find the arc length. We're going to multiply 10 over 1 times 2 pi over 9. So what is the answer to the question? 20 pi over 9 inches. The radius was in inches, so the arc length will also be in inches. That's a tricky one because it's in 2 steps. Got it? All right, here's one of these multi-part ones where we have to find everything. So we have to find sine, cosine, tangent, cosecant, secant, and cotangent. Well, they told me in the problem that the tangent is 1/2. That's in the problem. And that automatically means the cotangent will be 2. Is there someone at the door? Go ahead, let him in. Well, the wayward travelers have returned. Okay, so now that part is automatic for us, but now we have to figure out all the rest of it. Now this is where you have to have your beady little eyes wide open. Notice it says that the angle theta is between 270 or 180 and 270. See that, how it's written right there? So on your regular trigonometric graph, not the compass, this is not a plane sailing or plane flying or ship sailing. This is your regular labels. What does this mean? 180 to 270. What does that mean? It's in quadrant 3. So you're going to draw your picture in quadrant 3. And you are told that the tangent, here's theta, you're told that the tangent is 1/2. Right? So now we can do the Pythagorean theorem and come up with the missing side. So 1 squared plus 2 squared equals x squared. I got √5. But there's one more tricky thing about this. These guys gotta be negative, yep. Now, you might be thinking, but there's no negative in the problem. That's because what happened here? They canceled each other out. Right? They're both negative in that quadrant, but they canceled each other out. Okay, so now what's the sign?
-5/5.
Yep, -1 over √5 or -√5 over 5. Some of us are still confusing opposite and adjacent, and I truly don't know how else to explain it. Opposite means across from. So draw an arrow straight across the triangle, and that's your opposite side. Cosine then would be -2 over √5 or -2 √5 over 5. Cosecant is reciprocal of sine, so -√5 over 1. And secant is reciprocal of cosine, so -√5 over 2. Everybody follow along there, okay? Any question about that one? What does this tell me? What quadrant? That tells me where to draw it. Because you know you're going to draw a picture, and that tells you where to draw it. Okay, now we got some problems like we're on our quiz. We'll start with those two, A and B. Here we go. Let's How do I start? This is exactly what you did on your quiz. So 180 divided by 4 is 45, times 3 is 135. Now, I am older than the hills. I do this over and over again. If you can't do that in your head, it's okay. Over to the side, 180 divided by 4. I mean, do the math over to the side. It's okay if you can't do it in your head. Don't just guess. All right, so what do I do once I figure out it's 135? Draw a picture. Don't stop there. Don't stop there. That is not the answer. 135 would be over here. Right? How big is that angle? If this is 135, how big is this angle? 180 minus 135, it's a 45. What are the sides of a 45? 1 root 2. Anything negative?
Yes.
What?
The bottom
The
negative.
bottom one? I want cosine. Adjacent over hypotenuse. So negative root 2 over 2. Now some of you can just click through that, and that's awesome. Does anybody have an issue with any of that? Something I wrote there that doesn't make sense to you? Well, that was the same thing. Pi is 180 divided by 6 is 30 times 5 is 150. That math's a little bit easier, but again, you don't have to do it in your head. Write it down. Won't 150 be over here in kind of the same spot? Only this time the reference angle is 30. Am I going too fast? All right, what are the sides? 1, 2, and somebody said negative root 3. That's exactly right. And then what's tangent? Opposite over adjacent. So negative root 3 over 3. Sine pi. What about sine pi? What does that mean? Sine 180, and 180 is not triangleable because 180 is right here, right? Okay? So when you are on an axis, so if your angle is 90 or 180 or 270 or 0 or 360, if your angle is one of those, then you have to use your y and x definitions, right? So sine is y over r.
Yeah.
Now I know the radius is 1. Because that's the way I set my circle up to be just consistent every time. So 1 is my radius. What does that make this point then? Here's the origin. You're taking one step to the left. So what would this point be? Negative 1, 0. So x is negative 1 and y is 0. So y over r will be 0 over 1, which is 0. So the answer to the question is 0.
So is it 0 for all, like, through 69?
No. It depends what fraction you're building. I mean, there can be zeros, but they don't have to. If I used x instead of y, it wouldn't be 0, right? All right, next, secant 5 pi over 3. All right, how many degrees is that? Pi divided by 3 is 60 times 5 is 300.
Quadrant 4.
This one's gonna be in quadrant 4. So this is gonna be a triangle. You only do the circle thing if your angle is on an axis. Otherwise, you're gonna draw your triangle. If this angle is 300 degrees, how big is this one? 60. 360 minus 300. Remember, we always use 180 or 360. Never use those. So it's 360 minus 300. All right, what are the sides? 1 root 3, 2.
Isn't it negative root 3?
And the root 3 would have to be negative. And I want secant.
That's hypotenuse over adjacent.
Hypotenuse over adjacent. Very good. So that'd be 2 over 1 or 2. Hypotenuse over adjacent. Oh, we got a couple more. In this section. Now this was not on your quiz, but we talked about it yesterday. And I told you I'd tell you which quadrant to draw that in when it's a negative. So there it is. The next one's negative 3. Now, what's different about these? See that notation right there? That's different than this notation. So I'm still going to draw a picture, but this time, and it's in quadrant 4, but this time, I don't know the angle. I know that the opposite side is negative root 3, and the hypotenuse is 2. Right? But I don't know the angle, so I have to figure that out. Well, if that's a 2 and that's a root 3, that's a 1, right? And how big is the angle across from the root 3? That's a 60. So the angle is right here. So that angle is 300 degrees. Very, very good. See how it's a little backwards of the other ones? We know the sides. We find the angle. Kayla? I told you. Yeah, I'm going to tell you that information. There are rules, but we're not memorizing the rules. I'm just telling you. Okay? Now, the next one, you're going to draw in quadrant 2 and do exactly the same thing. Only this time, we know the cosine is negative 1 over root 2. So that's got to be a 1. And how big is the angle? 45. But 45 isn't the answer. Remember, this is the answer. 135. 180 minus 45. Remember, when we're in this quadrant, we always subtract from 180. Right? Wait, one more. We're going to get number 6, guys. In which quadrant is the sine positive and the cotangent negative? Okay, so think about it. Sine positive, cotangent negative. What do you think? Which quadrant does that happen? It isn't in quadrant 1, right? Can't be in 1 because nothing's negative there. So that's out. Can't be 3, why not? Well, x and y would both be negative, but that would make cotangent positive. Yes, it's not there. It's 2 or 4, good. It's 2. Now, here is what I want you to remember. What's the circle definition of sine? y over r. If sine is positive, kids, y has to be positive. Where is y positive? Up here, right? So if sine is positive, y is positive, and you have to be up here. Well, you already told me it can't be quadrant 1 because you got a negative, so therefore it has to be quadrant 2. All right, I will see you tomorrow.
Mrs. Ford, do you want me to stop your recording?
And review.
Going on the video.
Have a good day.
Thank you.
You're welcome.